What if the biggest obstacle to reaching Mars isn't Mars itself? Not the freezing deserts, not the poisonous air, not the radiation-soaked dust. What if the real danger is the distance, the empty, silent gulf between Earth and the red planet? Because before any human can survive on Mars, they first have to survive the journey there. And that journey may be the most dangerous crossing our species has ever attempted. Mars is not waiting next door. Mars is running away from us. On average, it sits about 140 million miles from Earth. But that number is almost meaningless, because Mars never sits still. Earth is moving. Mars is moving. Two planets racing around the Sun on different tracks, at different speeds. For most of the year, Mars is not just far away. It is on the wrong side of the solar system, hidden beyond the Sun, hundreds of millions of miles out of reach. A red ghost behind a wall of fire. We can only chase it when the orbits line up, when Earth catches Mars at just the right angle. That launch window opens only once every 26 months. Miss it, and Mars drifts away again. Not for days, not for weeks, for another 2 years and 2 months. The solar system does not care about deadlines, budgets, speeches, or human ambition. It moves by geometry, and geometry does not negotiate. Now imagine we make the window. The rocket clears the tower. Earth falls behind. The moon becomes a dot. Then nothing. No blue sky, no sunrise, no ocean, no horizon. Just a small metal spacecraft carrying human bodies across millions of miles of vacuum. With today's chemical rockets, the journey to Mars takes about 7 to 9 months. One way. That is not a road trip. That is exile. And getting there is only half the trap. Once you arrive, you cannot simply turn around and come home. Earth will not be waiting in the right place. The return window takes time to open again. A Mars mission is not a visit. It is a commitment measured in years. You leave Earth, you land, you wait. For physics, for orbital mechanics, for the planets to arrange themselves into a path home. But distance is not the only threat. The moment a crew leaves Earth's magnetic field, they enter deep space almost naked. Here on Earth, our planet shields us. Its magnetic field and atmosphere protect every breath we take. But on the way to Mars, that shield is gone. Beyond it, space becomes a storm, not wind, not rain, radiation, galactic cosmic rays, solar particles, high-energy fragments from ancient stellar explosions passing through metal, skin, bone, and DNA. NASA's Curiosity rover measured the danger on its way to Mars, about 1.8 millisieverts of radiation per day. The average person on Earth receives about 3 millisieverts in an entire year. In deep space, that same yearly dose can hit the body in less than 2 days. And over a full Mars mission, an astronaut could absorb over 1 sievert, close to a lifetime career limit for space radiation exposure. There is no perfect shield yet. Lead is too heavy. Water helps, but not enough. Magnetic shields are still not ready for real human flight. So the first humans to Mars will not be gliding through peaceful darkness. They will be crossing an invisible battlefield inside a spacecraft for months. And all of this happens before Mars even gets a chance to kill them. Because Mars has dangers of its own: thin air, brutal cold, toxic dust, and a surface with almost no forgiveness. But strangely, Mars may be the easier problem. We can design habitats, we can bury shelters, we can make oxygen, we can melt ice. The harder problem is the crossing, the silence, the radiation, the waiting. The knowledge that Earth is behind you, Mars is ahead of you, and help is nowhere. So maybe Mars is not impossible to live on. Maybe Mars is almost impossible to reach. And somewhere in that darkness between the world that made us and the world we want to claim lies the real question. Are we built to cross the void? Or were we only ever built to look up at it and dream?